Hey everyone! Have you ever stopped to think about what's actually happening inside your phone when you snap a selfie? Or how your favorite song gets from Spotify to your headphones? Today I'm going to show you why understanding how computers handle images, numbers, and data isn't just for coders. It's actually a superpower for your future. Let's start with something you use every day: images. Every picture you see on your phone or computer is either a bitmap or a vector. Bitmaps, also called raster images, are made up of tiny dots called pixels. Imagine zooming way in on a photo of your dog. You'd see a bunch of little colored squares, right? That's a bitmap. On the other hand, vector images are built using math, coordinates, and shapes, like lines and curves. That's why logos or cartoons can be resized without getting blurry, because they're vectors. Now let's talk about how all this connects to binary numbers. Everything a computer does, from showing you a TikTok to sending a text, is built on the binary system, just ones and zeros. Why? Because computers use physical switches called transistors, and each one can only be on or off. That's a bit, a single binary digit. Put a bunch of bits together and you get bytes, kilobytes, megabytes. You get the idea. So, how do you actually turn a regular number into binary? There are two main ways: the division by 2 method, where you keep dividing by 2 and writing down the remainders, and the place value subtraction method, where you subtract the biggest powers of 2 you can. For example, the number 13 in binary is 1101. Try it out. It's like a secret code. But here's where things get really cool. Those ones and zeros don't mean much on their own. That's where encoding comes in. Standards like ASCII turn binary into letters and symbols so you can text your friends. JPEG turns binary into images so you can share memes. MP3 turns binary into music so you can blast your favorite playlist. And when you compress an image, you're basically squeezing those bits into a smaller file, making it faster to send and easier to store. Let's take a real-life example from right here in Canada. In 2016, a major airline had a system failure that delayed flights all across the country. Why? Their computer systems couldn't handle a sudden overload of data. Too many bits, not enough backup. If they'd used better data compression or more reliable encoding, they could have avoided a lot of headaches. Globally, think about the 2021 Facebook outage. Billions of users lost access because a tiny configuration error messed up how data was routed, proving that even the biggest tech companies need to manage their bits and bytes carefully. So why does any of this matter to you? If you want to work in game design, cybersecurity, digital art, or even medicine, understanding how computers store and process information is key. These are the skills that power everything from Snapchat filters to self-driving cars. And right now, tech jobs are some of the fastest growing careers in Ontario and around the world. So here's my question for you. How could knowing a little bit about binary, images, and data compression help you reach your own goals? Whether that's building an app, designing a logo, or solving big problems in the world? Think about it, and let your curiosity lead the way.